We're studying IGCSE chemistry and we're starting electrochemistry revision 1. This is the first class in the series. And to recap, we studied everything about metals, but this chapter is similar to that, and we'll study this and then we'll move on to other chapters in it. Now, the first thing about this, what is this chapter all about, right? So we'll talk about the syllabus first. This chapter is all about a few things. We'll look at what is electrochemistry. Now, Noor, I think you have done this in extraction, right? Aluminium, bauxite, we did electrochemistry, remember?
Yes, I do.
All right, perfect. That it's similar to that, but it's completely different. Not completely different, a bit different. Now, electrochemistry is fine, and we look at not electrochemistry, but electrolysis. Next thing is we look at types of products and reactivity series. And after that, we look at galvanization and electrophy. Now, look, does this chapter feel a bit similar to what we've done so far, Diana? Have you done galvanization? Diana?
I don't think so.
I don't think so. Lula?
Yes, I have. We have done this. We have done this in the latest class we have had.
Latest class, right? Then let's start electrochemistry. What is electrolysis? That's the first question. Get your notebook ready. Start writing all of you. Electrolysis is breakdown of a compound in the presence of, or let's say by using electricity. Now tell me when you're done. Quick. Next thing we have is something called an electrochemical cell. Electrolytic cell. Now, what is an electrolytic cell? This is where we do the electrolysis. Now, look, if I have something in over here, okay, let's take any metal, or let's say I take molten sodium chloride, molten NaCl. What is this? This is called sodium chloride. Na is for sodium, Cl is for chloride. Fine. Now, our job is to realize if I have this as molten form, liquid, it actually exists as ionic as well. This is an ionic salt, or ionic compound. Now, the word ionic means that it can form ions. You may ask, what is ionic? Well, ionic is can form ions. Anything that can form ions is ionic. Any questions? Niranjana, I think you have done this with me. Have you?
Yes, sir.
Not Najla, Niranjana. I can't hear you, Niranjana. All right, good, fine. Now I can hear you. Now we have this much so far. Finish writing this quickly. And next, what you have to do is make this diagram, which will have these things. It will have two electrodes. These rods, or these rod kind of things, are called electrodes. Now, these electrodes are where all the magic happens. Fine. This is where all the cool chemistry happens, and we break something down. What are we breaking down? We're breaking down the electrolyte. This thing right here is called the electrolyte. The long one, always the long terminal, the bigger one is the positive sign, and smaller one is always negative. So the one connected with the positive terminal is going to be the positive electrode. Now these, by the way, are called electrodes, right? I told you that. Electrode. I know that. Now, fine. We have two kinds of electrodes. We have positive electrode and negative electrode. Well, the positive electrode is called anode. Negative electrode is called cathode. Any questions? Now, I'm not asking you anything, but any doubts so far? Any questions? Lula, Mavata?
No, sir.
No,
No, sir.
sir.
Now we have these electrodes, positive is anode, negative is cathode. Fine, we know all of that. Good. This one right here is called, let's remove this from here for a second. This right here is the power supply. Now make this diagram in your notebook because they will ask you this in alternative to practical and MCQ, especially. Even in theory, but not so much. Well, look, I know what the questions are going to be in the exam. So this diagram is guaranteed to be in the in ATP, alternative to practical. Now draw this quickly, and we'll start breaking things down. Now draw this and tell me when you're done. Meanwhile, I'll show you a diagram, a physical one. We'll talk about sodium chloride in a second, all right? Now, can you see this diagram right here? Mawadda? Machine class? Mawadda?
Yes, sir.
Can you see the diagram on the screen?
Yes.
All right. Based on this, since I've already told you, can you tell me what is the name of the positive electrode? Positive electrode.
Anode.
Anode. And Najla, can you tell me what is the name of the negative electrode?
Cathode.
Cathode. Perfect. Now we have these two things. And in real life, this is what it looks like. You have a big tank kind of thing, which is called a beaker. It's called a beaker. All right. And inside that, we have this power supply. Well, look at this person. He is turning on the switch. Right. And from there, the switch turns on. The bulb is also connected. So we realize there's electricity flowing. Okay. And now the thing is, we have to realize how do we use this? We know what it is now. We know how it looks and everything. Next thing is to use it. So start making the diagram. Lula, have you finished? Have you finished writing?
Yes.
Diana,
Yes.
right? Who is still writing? No one? Then I'm going to continue. Niranjana, have you finished writing?
Also.
Niranjana,
Yes, I finished.
I actually can't hear you. I think you're speaking, but try rejoining the meeting, Niranjana. Rejoin, quick. Now, next thing is we look at using electrolysis. Okay. Now, how do we use it? Niranjana, I still can't hear you. You have, let's try an example. Example 1. We'll try a substance such as only molten. Well, I'll tell you what kinds of substances we can have. We'll start with the molten salt, molten ionic compound. Before you write this, don't write it. Types right over here. Types of electrolytes. The types of electrolytes we have are quite some, like just 3, to be exact, 3. The first one is ionic compound. Well, no, just a second. Molten. The other one is aqueous. And the second one is not, the third one is not really in your syllabus. So this is all you need to know, molten and aqueous. The third type is in actually, which is quite different. It is in A levels. Now, both of these are ionic, by the way. So all electrolytes are ionic. They're molten ionic or aqueous ionic. Is that clear? Now, I want one of you to read it. But what the read these out loud. 1 and 2.
Molten ionic and aqueous.
Aqueous ionic.
Yeah.
Now, what about covalent? Why don't I have covalent compounds? Now, covalent compounds don't form ions. Lula, do they form ions? Do they form ions?
No, they don't.
So we can't use electrolysis. For electrolysis, we need ions. So no covalent, only ionic. Two types, molten or aqueous. Aqueous means dissolved in water. Najla, what is the meaning of aqueous?
It dissolves in water.
Right, perfect. Now let's try the first example. The first example is molten ionic compound. Let's try in the type 1. Let's write it as type 1. Now start writing. You should write this one and this one from here. First example we're going to take is molten sodium chloride. Molten sodium chloride. Now, what is the symbol for this? Now, I told you the name, but how do we write it? So we'll write it as NaCl, sodium chloride, and we'll have the symbol liquid. What is the meaning of molten? Molten means melted, or let's just say liquid state, liquid form. Right? Because well, metals are mostly solid. If you have a metal car, or you may see metals in cars and stuff, they're always solid. They're not liquid. But if you heat it to very high temperature, they become molten or liquid form. Next thing here is we have this as my electrolyte. So this is my electrolyte. Let's take it below. Electrolyte. Now my job is to find out what will be formed at anode. Products. I'll always have two products. Products at anode and at cathode. Anode and cathode, fine. There's one thing also, which is solution left in, let's say, left in beaker. Solution left. Now these are the three things we have to find. Before we find these, I'm going to tell you what anode and cathode are. So let's go back to the diagram right here. And just below the electrolytic cell, let's write anode and cathode. Anode is positive electrode. We know that. And one more thing happens here. Metals, let's say metals or positive ions, which are always metals, go to anode. But for cathode, the opposite happens. Diana, read from the beginning for anode and cathode, quick.
Anode, positive electrode, positive ions, metals go to anode. Cathode, negative electrode, negative ions, metals go to anode.
Just a second, there's a mistake. This is positive and this is negative. Yep. All right, that's how it is. Now, who else is in class? Niranjana, read it from the beginning one more time.
Anode, positive electrons, negative ions go to anode. Reduction happens. A gain of electrons. Cathode, negative electrons, positive ions, metals go to anode.
All right. Now quickly write this in your notebook. Now all that's happening is oxidation and reduction. Now this is very important to realize, to know this before we solve the question. Now, Mawadda, Najla, any questions?
No, I don't have any question.
So reduction at cathode, oxidation at anode. This is the final thing, right? Write this in your notebook.
Done, sir.
Done. Najla, Niranjana. I'll ask you a question, Nalula. Where does reduction happen?
Reduction happens at cathode.
At cathode, all right. Mawadda, where does oxidation happen?
At anode.
At anode. Najla, what kind of electrode is anode? Like positive or negative?
Excuse me, sir, can you repeat the question?
I'll repeat it. What type of electrode is anode? Positive or negative?
Positive.
Positive. Fine. Everyone finished writing? Who has finished writing, say yes, sir.
Yes, sir.
Yes, sir.
I've gotten 2 answers. Najla, Mawadda, Niranjana, tell me.
Yes, sir. I finished.
Yeah.
Yes, sir, me too.
All right. Now let's go back to the question. Example 1. Then this we had type 1 molten ionic compound, molten sodium chloride. Let's make ourselves the cell. Now, you don't have to draw this. Now, if I have a cell like this, I'll have 2 things. 2 of these. One of them is going to be positive, one of them is going to be negative. So positive, negative. Fine. And what is my electrolyte, Luna? Tell me. What is the electrolyte here? NaCl liquid. This is the electrolyte.
Yes. Yes.
Now, but what the problem is, it doesn't really exist like this. Since I know that they're ionic, okay, NaCl liquid, it actually exists at two forms. It divides into positive ion, Na plus, and Cl negative ion. Now we need to know this because all non-metals are always going to be negative. All metals are going to be positive, right? Now from here we realize that it will be Na plus and Cl minus. Fine. Now can you tell me which ion goes to the negative electrode? Which ion goes to negative electrode? The first one to answer gets 2 points.
Na plus goes
Na.
to the
Yeah.
cathode.
All right, so Niranjana and Lula answered first. Both get 1 point. Okay. Who else is here? We have Mawadda, Kiana, Najla. Let's call it N and I. That's it? Yes. Now we try to keep a little bit of competition here to make sure that everyone's answered. And for these points, you get something at the end. Now, so we know that this is going there. And next question, I need the answer in the chat. Where will the chloride ion go? Which electrode, anode or cathode? Answer in the chat.
Yeah,
I've gotten
to the
one
anode.
answer. To the anode. So only for one answer, Mawadda gets 2 points. First answer, and that's 1 point, 1 point. Niranjana, what is the answer? Perfect. Good. Now, but the issue is, I know what's forming. The product is going to be, I know that Na plus and Cl minus are going there. But that doesn't mean they are the product. They go there, that's fine. But they are not really the product. Now, let's see. Let's start with Na plus first. When Na plus goes to the minus thing here, the negative electrode, it goes here. And you know what happens? Well, why are things negative? Because they have lots of electrons. And when Na plus goes there, it takes an electron from the negative electrode, and it makes something. It makes something called Na, and that sticks to the electrode. Let's see what happens. So Na plus, when it goes to the negative electrode, the cathode, it gains an electron. Because we know what happens at, sorry, not at anode. We know what happens at the cathode. At the cathode, let's see over here. cathode reduction happens, gain of electron. So Na gains electron over here, which is called reduction. Now, if Na gains 1 electron, it's going to become Na0, because plus minus they cancel out, it will become Na0, which is basically an Na atom, sodium atom, solid. So from aqueous, from liquid to solid right here. Any questions in this part?
No, sir.
Thus, Na plus gains an electron. We know that because of the rule. Let's see what happens at the anode. Niranjana, read. What happens at the anode? Diana, read.
Oxidation happens, loss of electrons.
Loss of electrons. Fine. So that means Cl goes to anode, it will lose an electron, right? And when it loses an electron, it becomes Cl, because it had charge, and if it loses the charge, it will become just Cl. Now, any questions? What's happening here? Cl is actually a gas. Okay, Na is a solid. So what we'll see is we'll see Na forming on this. Na will be depositing over here. It will stick. Lots of Na will stick over here to the sides of the electrode like this. Okay. And at the positive electrode, the anode, what happens is that the Cl goes and forms. I'll show you. Let's take another color for this. Cl minus. It goes in, it becomes a gas. It basically goes in the air. Which gas goes away? Cl gas. Any questions?
No.
Now, one thing is Cl is actually a diatomic molecule. What is the meaning of diatomic? Niranjana, can you tell me? Diatomic means that you'll always have two of them. So I must
Like
have
it
two of
contains
these.
2 atoms.
Two atoms.
Yeah.
Therefore, I'll have 2 Cl minus losing 2 electrons to become Cl2. You don't have Cl, never. It's always Cl2. For hydrogen, it's always H2. For oxygen, it's always O2. For bromine, it's also Br2. So how do I know which atoms? They are so random, right? Well, the atomic molecules are always all group 7 and hydrogen, H2. Any questions? All group 7 and H2, right? So what are group 7? Let's see. I'll show it to you. Well, you know what group 7 is. Chlorine, bromine, and all of that. Just a second. When you look at the periodic table right here, can you see the periodic table on the screen, Najla?
Yeah.
Now, this is called group 7. And I have these fluorine, chlorine, bromine, iodine. All of these are always going to be 2. So F2, Cl2, Br2, I2, all of these.
I think
I hope
group
that's
7 is called group of halogens.
It's called halogens, exactly. And group 8 is called noble gases. But we're not looking at noble gases. Noble gases are always monatomic. So you can write this in your notebook later. Or you don't have to write it actually. You need to memorize it. So always diatomic. Now, we have these reactions taking place. What are these called? These are called half equations. What are they called?
Half equation.
Half equation.
Half equation. Perfect. So, well, what does that mean? Well, I am dividing the whole thing into 2. So 2 means basically half. And to get the final equation, I'll have to add these together. We'll do that later from the next example, perhaps. But let's see what is left in the solution. Okay, if Na goes there and Cl goes there, nothing is left. Right? Any questions? Or let's say finishes. Or let's just say it's used up. Because Na goes there, Cl goes there to the anode, Na goes to cathode. then nothing will be remaining in the solution, right? Everything will be finished, used up. So you should write nothing in your notebook. Write used up. Now the next thing is, let's actually look at the full equation. It's not called full equation. It's called something. The name is a bit different. It's called net equation. And not just net equation. These are called ionic half ionic equations, and these are called net ionic equation or ionic net equation. These are ionic half equations. Now, how do I find the net equation? Well, my job is to take the two equations. Let's take them. 2Cl minus 2 electron gives us Cl2, and Na plus electron gives us Na. That's what I have. Now, Liana, tell me how many electrons are lost in the first reaction? How many electrons are lost in the first reaction?
2.
2. And how many Mawadda are lost in the second equation?
1.
1. Now I have 1. But the problem is, I need to remove the electrons. Okay. For that, I need to make the number of electrons common or same. So step 1, number of electrons may let's say equal. Now don't write this right now, just focus on the class, pens down. I'll tell you what to write later. So first step, Najla, read.
Make numbers of electrons equal.
So let's do that. To do that, how do I do it? If I multiply this equation with 2, okay, what will I get? I'll get 2Cl minus 2 electron. That's same, that doesn't make a difference. But this guy will change, it will become 2Na plus 2 electron gives us 2Na. So I multiply the second equation with 2. Any doubts?
No.
Second step. Add them. Add both equations. Niranjana, I want you to add these equations for me, quick.
Two CL.
2Cl. Speak louder. Then
Plus 2Na.
2Na plus and gives us. Well, let's also write this actually. So we'll get minus 2 electron plus 2 electron, and which gives us Cl2 plus 2Na.
Yeah.
Now the point is, these minus 2 plus 2 cancel out, right? Right,
Yeah.
Lula?
Yeah.
So let's remove that. We don't have to write that, and this is called our net ionic equation. Any questions?
No.
No.
Nothing.
Now, this is the net ionic equation. We have the half equation. We have the solution. What is half the solution left? Now, I need you to write this beginning from here. So start like this. What should you write? I want you to write this, everything in blue. So this part, don't make the diagram, and write everything else. Now your job is to tell me when you're done writing. Fine. All of that. So start. Except the
So
diagram, write everything. Yes, who was it?
Sir, do you want me to read or write?
Right. In your notebook.
Okay.
I need all of you to write it. Right, and quick. So all you have to do is type 1 molten compound, then example number 1. And this is my first example. We'll look at one more example in this, and then we'll go to the aqueous ionic form. You should also write this part.
Sir, can you show the down parts?
Okay. If anyone needs me to go higher, please tell me. Najla, are you writing?
Yeah.
Yes, sir.
Good. I think we'll need a nickname for Najla or Niranjana because their name is the names are kind of similar.
Yeah.
We need a nickname.
N1 and N2.
N1 and 2, right? We'll call them Na and Ni, nickel and sodium. So Najla is Na and Niranjana is Ni. Mavadda, progress?
Well done, sir.
Yes, sir.
Done.
I'm writing the ionic equation.
All right. Who's finished writing? Niranjana, progress?
I'm still writing.
Still writing. Now it's good that you guys are writing. That's amazing. And write quickly. Anyone, any doubts so far?
No, sir.
No. Right. So we'll try to do lots of questions. And look, the thing is, you may think you don't have doubts, but when we do questions, that's when the doubts come out. So we'll try questions. Especially in the IGCSE exams, it's not enough to just write the answer. It's enough. You need to know the format for each answer, what the examiners are looking for, how to get the A star. Because our final goal is for me, all of you should get A stars. Is that clear? Now, please don't think of, let's say I want a B or an A. Well, A is fine. A doesn't make a difference, but B is not acceptable. Right? Anyone who's trying to get a B over here? And who's trying to get an A star? Say yes.
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 Yes. Yes.
That's right. Now the thing is, you'll only get an A if you're hoping for an A. You get an A star A when you try to get an A star. That's how it works. Not everyone gets A star. It's very difficult. The percentage is 95% for an A star. For A, it's 85%. Now, if you let's say you're trying for an A, then you'll get a B. So try for A star. Inshallah, you'll get A star. Even if you get an A, it's not you tried your best, right? That's how it works. Now, can I continue? Everyone's done? Niranjana?
Yeah.
All right. The next one, which we're solving, just a second. Now, next example, example number 2. Example 2 is going to be everything about some other metal. Okay, some other compound. What kind of compound can we take? Let's look at the periodic table. I want Najla to cook something. Whose hobby is cooking? Najla, right? And I think, yeah. Cooking or painting? Painting, right? Let's see.
Yeah.
Now, all right. Then I want Najla to paint a compound for me over here, and Diana to work with her. So I need one metal and one non-metal, which we're going to use as an electrolyte in the second example. So we know that all of these are metals, right? This is metal, this is metal. All of these are metals. These are called transition metals. This is called alkali metal. So quickly choose any metal and give it to me. All of these are non-metals. Najla choose a metal, Diana choose a non-metal.
Iron.
Iron, sure, we'll take iron. Okay. Iron is Fe. Now Diana, non-metal.
Carbon.
Carbon. Okay, that's good, but that's a very. I want another one. Why not carbon? Because carbon does not really like to form. Carbon wants to stay out of all of this, right? He's busy. Let's try another one.
Fluorine.
Fluorine, right? That's a strong metal, strong non-metal, right? The carbon is a weak non-metal, so it only forms covalent compounds. Covalent. And it doesn't like forming ionic. He's like, I'm busy for all of this. Please keep me out of it. So transition. And I have alkali, the third group 1. You know all of this. And last is this earth metal. Now, let's take iron and fluorine. Okay, how do I form the compound? Well, the compound is going to be molten iron 3 fluoride. Now I have to write the 3 there because obviously this is a transition metal. For all transition metals, I have to tell them the charge or the oxidation state. Iron fluoride looks like this. Iron, Fe, F3. Now I'll give you the ions as well. The ions are, let's try the ions here. Ions are Fe3 plus and F minus. Now your job is, now we're not going to draw the electrolytic cell. Okay, what we're going to directly do is we'll write the products. Start writing this as well on your notebook. Now products, the products are at anode, at cathode, and remaining on left in solution. Let's start with the anode. Now, which of these ions will go to the anode? Lula, answer. Lula, which of these ions will go to the anode?
Fe.
Fe. Anode? No, that's not. I'll tell you. Let's look at this. Negative is cathode.
I meant
Positive is
F minus. I meant F minus.
F minus, that's fluorine. What is it called? It's called fluoride. ion, fluoride ion, and iron ion. So we have Fe3 plus and I have F minus. That's my electrolyte. Okay, so I know that F minus will go to anode. And Mawadda, tell me what happens at the anode. Reduction or oxidation?
Oxidation.
What is oxidation?
To lose the electrons.
Lose electrons. So it has one charge minus, it will lose only one electron. Because the end goal is to become an atom. Okay? The charge should become 0 at the end. So to make it 0, I'll have to remove one negative. Now another thing is these are diatomic, right? So I'll have to make this 2 and this 2 and this 2 and multiply everything with 2. Fine. Niranjana, what will form at the cathode? Niranjana?
It will be -2 minus.
No. What will form which one? Fe3 plus will go to the cathode, or Fe minus will go to the cathode?
Fe3.
Fe3 plus.
Yeah.
The plus is the big thing, right? And what will happen at the cathode? Oxidation or reduction?
Oxidation.
No.
Wait.
Read from your notebook.
It will be reduction.
Reduction. Najla, what is reduction?
It will gain ions, electrons, sorry.
Gain how many? 3 minus.
Three.
Because
Yeah.
3 plus, and this will become Fe3. Fe solid, this is F2 gas, because metals are solid and non-metals are gas. Next thing, we have the products. Good job, everyone. All right. Now, one thing is a problem here. We don't write it like this. Now, I would like to take this to the other side. And what happens then? If I shift it, let's say I take this to the other side, it will become plus. Right? Minus will become plus. And that's what happens. So now we're doing a different kind of way of writing it. I know it's a reduction, but if I take electrons to the other side, it will become like this. Then what are these called? These are called half equations. Done. What will be remaining in the beaker? Dula, tell me. What will be remaining in the beaker?
Nothing is left. Everything is used up.
Everything is used up because look, everything is going somewhere. We don't have, let's say, H plus here, which doesn't go somewhere, right? We don't have any of that. We'll just say used up. Now I'll get my net equation. Now I won't help you with this actually. It's your try now. I'll take one person and the others have to solve it on their own. So let's start. Mawadda, Najla, solve it in your notebook and send me a picture.
Okay.
Okay. So
Can you do it? Mawadda, Najla, can you do it?
yes.
Okay.
All right. Try. No worries. Now next one is I want Lula and Niranjana to try it on your own as well. Diana, do you want to try on your own?
Sure.
Sure. Then Niranjana, wait with me. Now look, Niranjana, mic on quick. By Niranjana, I mean nickel. Ni.
Yes, sir.
Now start. How do I find the net equation? What is the first step, Niranjana?
First we will take any two compounds.
Well, now I have the half equations, right?
Yeah.
First step. Now check your notebook for the first step in the last example. Read it out loud.
We can take Na and
No, read this part. Step 1. Out loud. This
the number of electrons equal.
Okay. And what is the second step?
Add both equations.
Fine. Now, see, first step was make number of electrons equal. Is the number of electrons equal in both equations?
It is.
Now it's 3 here. And how many is it in the, how many here?
It is 2.
The top 2. So I want to make them both same. One thing I can do is I can multiply. That's like simultaneous equation here, right?
Yeah.
How do I solve it? What should I multiply both equations with?
3, so it will be 6.
And this with?
With so both sides it will be 2. Like 6.
2. We'll get this equation. So 3, that will become 6f minus
Plus gives us
gives a
F
yeah.
2 gas plus 6 E minus.
electron. Now next one.
It will be Fe 2 Fe3 plus 6 E minus
plus 6 E minus. Then
gives us 2 Fe.
2 Fe. All right, good job, perfect. Right. So if this was 4 marks, you'll get 4 out of 4 for this. Now next, that's done. What is step 2? Step 2 is add. Now tell me the final answer, Niranjan. And by the way, whoever is doing on the notebook, you have to send me a picture in WhatsApp. Quick. Pavada, Najla, send me a picture on WhatsApp. Even Lula and Diana.
So it will be
now, yeah. So it will be
2 Fe.
2 Fe3 plus. All right. Then
minus
one more time.
Plus E minus.
Plus 6 electrons. I don't want you to say E minus. Say electrons. Okay.
Okay.
Yep. Sure. Okay. Now next.
Gives us plus 6 Fe F minus gives us 3F2.
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 Plus
6 E minus.
Again, electrons. Now, Niranjana, what do you think is same on both sides?
Both sides, the 2F E minus, the 2 sides, they have the same.
We'll cut them out.
Yeah.
So we'll just remove
cancel it out.
Answer. Now that's my answer. Ta-da!
Yeah.
Good job. Any doubts?
No, sir.
No? Amazing. Now write the whole thing in your notebook. Tell me when you're done. The rest of you, any doubts? Send me pictures quick. I've gotten one answer from Mavadda, I think. Let's see it. Mavadda, is this your answer?
Yes, sir. It is.
No. All right. The rest of you, send me the picture. Niranjana, write this or the whole thing in your notebook. Now look, things may look easy with me because I teach everything in great detail, but we have to be ready for the partial questions. So whenever you have assignments, please do them. Now, okay, let's solve this one. 6F minus 6 electrons, 6 electrons. Good job, good job. Perfect. Right, easy. Now next thing, Lula.
Asma, I have a doubt in
Ask me.
the one that is okay.
Let's look at your answer first. You have the correct answer. Don't worry. What is the doubt? Tell me.
When I have a now, for example, after I cut, do I write them separately or just I show them how I cut it and then I write it separately, just like leave it there?
Yes, sir. I have the same doubt.
You have the same doubt. Now
Yeah.
you can cut it, but I'll tell you, don't write it in the first place, right? So just don't write it. Okay. In the final answer, you just have to write 2 Fe, 3 plus, like Mawadda. So you don't have to show this at all. You don't have to cut it either.
So I
Just
don't have
remove
to
it in
show
your
them
mind.
the cutting process.
No, you don't have to show. Does that answer your question?
Yes,
Who was the other one? Who
that
had
was
it
it.
out?
Najla had the same doubt as me.
All right. Najla, understood?
Yeah.
Perfect. I've gotten Diana's answer. Diana, is this your answer?
Yes.
Now there's one problem here. Yep. Yeah. So far this is correct. But when you add them, I think you're missing something, which is 3F2. And 3F2. Okay. Now, Diana, let's try adding them together, right? So I have 6F. I'll write that here. Diana, work with me. Now this part is wrong. So we add it. All we have to do is add this guy and this guy together. So what we'll get is 6F minus plus 2Fe3 plus. Then I'll get plus 6 electron on the left hand side. Everything before the arrow, add them together. So all of this and this. Now next thing is I'll add these together. 3F2 plus 6 electrons plus 2Fe. Diana, any questions?
No, sir.
Now what is same on both sides? Exactly the same. Six electrons. And if I ask you, Diana, do you have Fe3 plus on the other side?
Fe3 plus? No.
On this side you have it? No, it's only on this side. Do I have F minus on this side? Any F minus here?
No.
No. So I can't remove them because they're unique. They're not common. But the only thing which is common is this one. 6 electron and 6 electron, right? So the
Yeah.
final answer will be whatever is left. So I'll just remove this. And you can cut this out directly in this process. 6 electron and 6 electron. Now, Diana, can you tell me why did you cut 6 electron and 2 Fe? Explain quick. Niranjana, I haven't gotten. No, I think you have done it, right? Who's Najla? I haven't gotten your answer. Quick, send. All right, got it.
I
Now,
send it.
Diana, do you understand? Do you understand how we cut the things and how we
Yeah.
remove the common?
Yeah.
All right, then that's good. Now write this in your notebook. Well, you have to write the whole thing in the notebook because that's the second example. This method is the same thing you're going to copy in your exam. So I'm just going to check Najla's answer. And then we start a quiz examples. Now, good. Then we have cut. All right, good job. Anyone, any doubts? Niranjana?
No.
No. Now we're looking at type 2. Right? I give everything in an organized manner. We have two types of equations, right? So type 2. Type 2 are called aqueous electrolytes. Or aqueous compound. Let's just say aqueous compounds. All right, what are these? Well, look at the first example. Example 1. First example is, let's say, again, I want you to make I want you to cook something for me from the product table. Just a second. For this one, I want Lula and Niranjana to tell me one compound, any metal, non-metal salt. So take one metal and one non-metal. Quick, Niranjana and Lula.
What do I take, metal or non-metal?
Your choice.
I can take barium.
Barium, right? Okay, I have barium. Now, instead of barium, I want you to try one more because barium is insoluble. It doesn't dissolve. Try one more. Quick.
Potassium.
Potassium, it dissolves easily. More reactive, right? Now, who's remaining? Who's remaining? Niranjana, tell me any non-metal. Quick, choose.
Oxygen.
Oxygen. Amazing. Let's try. Aqueous compounds. Example 1 is Na2O, aqueous. Now, what is this called? Can someone tell me the name of this? Mavadda, what is the name? The word name.
Sodium oxide.
Sodium oxide. Okay. Now, someone tell me the ions. Najla,
Yes.
the ions from this. If I break this down, what ions will I get?
Yeah. Na
Na
and O.
O. Well, Na is plus, O is always 2 minus.
Yeah.
Right? Now products. Now this gets tricky. There's one more thing actually. There's not two. There's more here. The other two are called H plus and OH minus. Well, where did these guys come from? Well, they're just joining the party. If I make, let's say, this is where the party is taking place in a beaker, and now it was just 2 people in the party. Now more people are joining up. They're showing up. They want extra food. So if I make the things here, electrode first, and I have my electrolyte, Na plus and O2 minus, but I also have H2O, the water, this aqueous part, right? H2O, and H2O breaks down into H plus and OH minus. Is that clear? H
Yeah.
plus and OH minus. Now this, well, I also have my electrodes, which is plus and minus. Plus here, the positive one is called anode, negative is called cathode. Perfect. Now let's start the party, and we're going to make the products, right? For that, I'll turn on the circuit and electricity starts flowing. Everyone's happy, and we'll get some products. Product at anode and cathode. But the issue is, it's not so simple. It's not as simple as you thought in molten. It's quite different. Now, since these new people have showed up, something different happens. I won't ask you, I'll just give you the products right now, write it down. Okay. So the product will be Na plus at anode, which gains electron and becomes Na solid. Now it's not liquid. It's aqueous now. Na plus aqueous. Cathode, I have OH minus plus 4OH minus plus 4 electrons gives us 2O2. No, just a second. O2. Write the whole thing in your notebook. Tell me when you're done. Now this strange equation is what is showing up now at cathode. What is this H2O and O2? We'll look at that in a second. But quickly finish writing. Tell me when you're done. There's a mistake here. There's a mistake. This is going to be cathode. The positive one goes to negative electron. Negative goes to positive.
Done, sir.
Mawadda, Diana,
Done.
Sir, I'm still writing the anode. Just give me a second.
take your time. Niranjana with the NI,
Yes, sir.
finished?
No.
Take your time. Are you understanding? Any questions?
No.
Now, well, that's something. You'll have a lot of questions in this part, right? Everyone will have, but we'll look at that
It's
and
kind of
easy.
confusing because there is aqueous, then at the end it is liquid, and then there is gas.
Right? So many things.
Yeah.
We'll talk about that. Look, science, look, why will they test you on something easy? And like life, things have to be difficult. That's why people test you. And if you're good at things which are difficult, everything becomes easy if you practice hard enough, or if you practice. That's all I can say. Practice. Not study, but practice. You can study one day and it will still be difficult. But if you practice for, let's say, 20 days, it will be like a piece of cake. So this will get easy. Finish writing first. As soon as you're done writing, say yes. Or finished.
Yes.
Now the next thing we're looking at is remaining. Okay. So the remaining, or let's say left in solution. Let's just say remaining. Yeah, makes sense. Remaining. Remaining will be, what is remaining? Look, now Na goes somewhere and OH goes somewhere. So this guy and this guy are gone. Who's left? H plus and O, right? H plus and O are left. Therefore, what we realize is we'll have H plus ions, or what we'll really have is H plus ions plus O2 minus ions, which will give H2O. So let's write it like this. Just a second. 2H plus plus O2 minus plus H2O. So what is H2O left? Write this as well. Now, the only reason it's confusing is we have no clue why are the products there. We know why Na went there, and it's positive, obviously goes to negative, fine. But why did this OH minus go there? So confusing, right? So we'll start with the rules. To make life easy, we have some rules for every topic like physics, chemistry, maths, everything. We have some rules. The first rule is rule for products, or let's say aqueous products at, or rules for products at cathode. Niranjana, have you finished writing? Najla?
Yes.
Yes, sir.
All right, let's move on. The rules of products. Now, I'll explain why this happens afterwards. This was just to just give you a hint of what's happening. Now, rules for these. Rules for the products at cathode. I want to put the word aqueous right here. Let's just put aqueous. Aqueous product. Done. Now, first thing first is I'll make something called the reactivity series. Has anyone memorized it here? Have you memorized the reactivity series?
No, sir.
The ones that you gave us, right?
Yes. Yes. Reactivity series. The metals.
Yes, I remember them.
Tell me.
Like by letters or by names, like full.
Just the name, the letters.
Okay. K,
K,
Na, Ca,
NaCl,
Mg, Al, C,
All right, now I'll write
ZL.
it quickly. All right, let's write it quickly.
Okay.
Kankama zaf sab. Now this is the reactivity series right here on your whiteboard. Now these are, look, well, it's so long, it's so confusing, but you'll have to memorize it. There's no way around it. Memorize it by heart. This whole
And
thing.
also, remember that group 1 is the most reactive, group 2 less reactive, group 3 least reactive.
Yes. Now we have some over here. We have carbon. Carbon in between of magnesium and aluminium, and no, not yeah, right there. And we have not there actually, right here after aluminium. Carbon. Write this in your notebook. Reactivity series. You have to. And over here, just above copper, we have hydrogen. Well, carbon is not a metal, so it's not inside. It's there, but we're writing it differently to make sure that you understand where is carbon. Carbon is between aluminium and zinc, and hydrogen is between lead and copper. I'll read it out once. Potassium, sodium, calcium, magnesium, aluminium, zinc, iron, tin, lead, SN is tin, lead, copper, AU is actually no. AU is gold, AU is gold, AG is silver, and PT is platinum. Now what we realize is, write the rules. The rule is, let's just say the rule. Rule 1. If no metals present, or let's say if no metals less reactive than hydrogen present, then H2 gas forms. Right? That's the only rule actually. There's no rule 2. That's it. Done. Finished. Now someone has to read it out loud. Niranjana, read. From here. Niranjana,
Yeah, sir.
read the rule for
No
aqueous
element.
product at cut.
Okay. Rule: if no metals less reactive than hydrogen present, then hydrogen H2 gas forms.
Now I'll give you examples for this. Just put this here. No metals less reactive than hydrogen. What are those? These are, let's just write it here. Copper, Ag, Au, and Pt. So the ones at the end. If these guys are not there, then always hydrogen will form. Is that clear?
Yes.
So there, okay, that's fine. Done. Now let's look at the rule for. I'll give you an example. Let's say, example. You have, let's say Zn 2 plus H plus present as ions. What will form at the cathode? What will form at the cathode? Rihanna, tell me. Diana or Lula, tell me. Diana, tell me which of these will form at the cathode, zinc or hydrogen? If zinc metal is present, so will hydrogen form or will zinc form?
Zinc will form.
It's zinc.
All right, zinc. Let's write it. We'll add one more rule here. Only if, write this in your notebook. Present, then they form. Otherwise, H hydrogen, H plus H2 gas forms. Now I want you to remove the first rule. Cut this out and write it here. Write this rule. Diana, read it out loud.
Only if copper and silver, gold,
Copper, silver, gold, then platinum,
platinum metals less reactive than hydrogen present, then they form. Otherwise, hydrogen H2 forms. Gas
that's
form.
always. So I'll give you the question again. The question is, now this time I want Mavadda or Najla to answer. Okay. Now look, mic's on, Najla, Mavadda. Question is, if I have copper and I have H plus, which will form? Copper or H plus at cathode? Cu2 plus and
copper.
Copper. Okay, I have copper forms. Question number 2. Mavadda, if the ions present are, let's say, potassium and H plus, which will form?
Hydrogen.
Hydrogen, right? Last question, Diana. If you have Au and H plus present, which will form?
H plus.
No. Read the rule one more time. Don't read it, Asha, I'll tell you what's happening. Now, only these guys form if they are present. So if you have Cu, Ag, Au, Pt, they will form always. Okay, if they are present. So if they're not present, then H plus. So since Au is present, then it will form. Is that clear?
Yes.
Because it is less reactive than hydrogen. So the one which is less reactive forms. Now you have to memorize this rule out by heart. That's only the way you can memorize it. I've given a very small, tiny rule, right? So if these are present, they will form. Otherwise, always hydrogen gas. Now, I just want you to write one thing, then the class is over. Rules for the aqueous products at anode. I won't ask questions on this. We'll do that in the next class. The rules are, if concentrated halide ion, or let's say Cl, or let's say examples could be Conc, or let's just say Cl2, or yeah, ClF, Br, I. If these are present, then they will form. Then they form. Otherwise, always OH minus gas forms. Pavada, read it out loud.
If if conc
Concentrated.
Concentrated halide ions FClBr present, then they form. Otherwise, always hydroxide forms.
Hydroxide or O2 gas forms. So hydroxide to this guy. Okay. The equations are, you need to memorize this. The equations are, if hydroxide is forming, then OH minus. Let's say, if no concentrated halide, then OH minus gives us 2H2O plus 4 plus O2 plus 4 electrons. That's the equation always. That is always the case. Memorize it. It is never changed. Now, but if concentration halide present, then what happens? Well, what happens then is that you'll have halide, let's say X minus plus E minus gives us X2. Write this in your notebook, tell me when you're done. Now, but one question you may have is, what is this X over here? X could be anything. It could be F, it could be Cl, it could be Br, it could be I. So if a concentration halide is there, then you have to do this equation. If it's not there, then it's always this equation. Is that clear?
Yes.
Now in the bottom, just write one more line, which is complex ions never form. At electrodes. What are these complex ions? Let's say PO3, let's say PO4, or I'll say not over there actually, I'll write it here. Now finish writing this, tell me when you're done. All right?
Done.
Done. Diana, Niranjana,
Yeah.
Sir.
writing.
Yep.
All right. Now finally, the examples of this could be Zahra, can you hear me?
Yes, sir, I can hear you.
Now stay after class for 5 minutes. Start writing this in your notebook. Now this is PO4, 3 minus, or we can have SO4, 2 minus, or I can have NO3 minus. Now these guys never form. These are called complex ions. Is that clear? Never. It's very simple. If you have, well, I'll stop saying now. Finish writing, and we'll talk about this in the next class. Right? Any questions, anyone?
No, sir.
No.
No. We'll solve question number. Now it's very simple. If concentration halide ion is there, then you have this equation. If it's not there, always this equation, right? So it's only two options. Same thing in the anode. If you have anything copper, platinum, silver, gold, then they form. Otherwise, always H plus makes hydrogen gas. Now you guys would be shocked to realize the chapter is actually over. We only have 10% remaining, so it's 90% done. The only thing we have in the next class is going to be electroplating. Then chapter is done. I don't think you guys have doubts, do you? Because, well, it's fine if you have doubts. We'll practice questions in the next class. All right? It's totally normal to have doubts. Now, who is still writing? Niranjana finished?
Yeah.
Yeah, all right. Niranjana, give me a recap. What did we study in this class?
We studied about electrolysis and how to make all the equations same and how to make equations, and then the rules about
All right.
correct.
All right, just a second. Najla, continue. The sodium, Najla. Yes.
Yes, sir.
Recap. What did we study in this class? Other than molten electrolysis, what else did we study? Recap, quick.
We studied about the anode and cathode and what they are.
What they are. Mawadda, just recap so I
Yes.
know you remember what happened in this class. Recap. What did you learn in this class?
We learned about electrolysis and the electrolytic cell and the uses of the electrolysis and how we use electrolysis with metals.
All right. Lula, the last part.
We learned about the net ionics and the products and the types, and we learned about aqueous compounds with the rules of when we learned
Rules,
about
yeah.
the reactivity series too.
All right. Now, what is the next class, Lula?
For the next class, we'll be studying about electroplating.